Chapter number 4, correlation. Under this chapter, first of all, we need to learn what is bivariate data. Bivariate mean two variable. So data from two variables. Bivariate data is a data which has pair of values for two variables. For example, assume rainfall for 6 months. And the paddy harvest rainfall is 60 milliliter. Let's say paddy harvest is okay, in this is in 20,000 kilo. I write kilo in thousands 20, and if this is 65 milliliter, the paddy harvest is going to be 21,000, and it is 70 milliliter. This is going to be assume 25,000 and 80 milliliter, then it is going to be 28,000. So likewise, now rainfall is one variable and the paddy harvest in kilogram in another variable. So assume this variable is x and this variable is y. So if I need to represent this data in a scatter diagram, so this is going to be x and this is going to be y. So I am marking 60, 65, 70, 75, 80, and then 20, 21, 20, 25, 30. So in that case, 60 to 21 data, 65 to 25 somewhere here. So number 70, it is 25, 21 here, and 25 and 75. If it is 80, it is going to be 28 somewhere here. Likewise, so I put this data into a scatter diagram. So now those are the pair. So when I put this data into a scatter diagram, so 80, okay, right here, 60, 20, 65, 21, 70, 25, 80, 28. Those data, the pair of data values. So those are the pair of data values come from those x and y variable. Actually, this is ordered pair. Ordered pair means first x then y. So usually we tell that this x is independent variable. Independent variable, or we can tell that this is independent variable or explanatory variable, this x1, and y variable we call dependent variable or response variable. When you put the data, the bivariate data like this in this scatter form, then we can study about the linearity or the linear relationship between those two variables. So that study is correlation, or correlation, we can tell that, or correlation describes the nature of the linear relationship between two variables. So correlation describes the nature of the linear relationship between two variables. For example, if you get this graph, so now you can see that there is a linearity. If you got this graph, right, there is a linearity. But if you consider this one, so there is no linearity here. Let me take another one. Semicircle. So there is no linearity. So likewise, the correlation describes the nature of the linear relationship between two variables. So in these two variables, yeah, there is a linear relationship, there is a linearity. Now there is a linearity, but there's no linearity or linear relationship, and there is no. Now there's no linearity, there is linearity, and there is no linearity. If there is a linearity, it means this data can represent by a line in other way. Instead of all the data, those data can be represented by a line. When you consider a line, the gradient, the one feature of a line is the gradient. So in that case, we can tell that this is positive gradient and this is negative gradient. Because of that, we can tell that this is positively correlated and this is negatively correlated, because the gradient is here positive of this line and the gradient is negative in this. In other way, we can assume this is x and y, this is explanatory variable, this is response variable. If it is a positive gradient, positive correlation, then explanatory variable increasing, y also increasing. Explanatory variable decreasing, then the response variable also decreasing. In contrast, the other one, the negative correlation, when explanatory increasing, y is decreasing, and x is decreasing, then y is increasing. So you can tell the positive and the negative relationship in this way as well, as a relationship between variables. When one variable explanatory is increasing, response also increasing, response variable also increasing, it means it has a positive correlation. In here there are no correlation, so no correlation, you can see that zero correlation. In here also zero correlation. Yeah. Now let's discuss the causal relationship between two variables. Now correlation also a relationship, but causal also relationship. The correlation is a relationship about the linearity. Causal is the relationship, is the the reality. The causal is the relationship between two variables, in other way, reality. So it's a if a change in one variable causes a change in other variable, it means x variable change, then it goes to a y, and y variable change is goes to a x. If y variable change is goes to a x, but some variable has this feature, but some variable it doesn't. For example, when you look at this one, x and y rainfall, right? Yeah, paddy is getting increase because of rainfall, but it is x to y is fine. But assume that because now paddy is increasing, so y is increasing. Can you bring this arrow to left side, that because of rainfall it is happening? Who knows? It can be because of fertilizers. So then it is one way, because yeah, x to y it works. When the rainfall increase, paddy harvest is increasing. But paddy harvest increasing doesn't mean that the rainfall is increasing. It could be the fertilizer. So then the causality. So there is no causality in between those two variables. Now in here, at least during rainfall and why, there is one side. So this side is not exist. But sometime in between variable, there is no meaning at all. For example, assume if you take a city, so you measure the rainfall of the city 60 and number of cars, let's say 2000 or 4000. So you measure number of rainfall in milliliters, and rainfall is milliliters, and the number of cars, and you draw um, uh, let's say this is A and B. So you draw a scatter diagram. You can see that this kind of relationship. Okay, it is a really linear relationship. So it has a positive correlation. But what is the causality? There is no causality at all, because the rainfall not depend on the cars. Cars not depend on the number of cars, not depend on the number of the amount of rainfall. But still, you can see a positive correlation. So in that case, in these two variable A and B, there is no causality at all. So we need to understand. So the only way we can understand the causality with our common sense by reading the question. Uh, when you look at example 1, it is about a distance with the population density. The scatter diagram you can see. The first question is, draw a scatter diagram represent the data which is up here, and describe the correlation between distance and the population density. You can see that we can represent that data by a line, and that is a negative line which has negative gradient. So then we can tell that it has a negative correlation and weak negative correlation. Weak mean when one variable is increase or decrease, the response of the other variable is very low. Weak mean when one variable increase or decrease, the response of other variable is very low. And part C, interpret your answer to part B. Yeah, interpret your answer to part B mean you can see when the distance is increasing, the population density is decreasing. When the distance is increasing when going to this curve. This height becomes smaller, popular densities. So this is the characteristic of the negative gradient. And example number 2, when you read, the objective of this question is to show that the correlation is not precise or less accurate when you have a small sample. So he took that the sample size is 14. So this is the issue, because correlation we have to uh, consider from a big data set. So instead of that, the 14 is very less amount. So this is one thing you want to consider, that if there is this kind of questions, so this is a possible answer, that the sample size is very small. So then it's difficult to get predict. Also, another thing that in this correlation you can see that, for example, we have this kind of data, and we have two outliers, actually two extreme datas, and we decide this is a line. So this is something we have to careful, because it give a mis understanding, that is look like line, which is not always. Let's discuss exercise 4 now.